7365. Is that correct?
That is good. I'll start the recording now. All right, so let me share my screen. And Marisha didn't show up, so we'll just go ahead and get started anyway. Okay, so, oops, there we go. All right, so we have finished all of chapter 1, which is what I was saying. See, we went all the way down to topic 4. We're done with topic 4. So now we're going to topic 5, which is actually chapter 2. Okay, so the new stuff is about the periodic table that I gave you in class. Now there is another periodic table. There is a periodic table that you can get. I think it's right here. If you don't have one already, yeah, right here, see it? You can actually click on that and you will always have a periodic table. See that? It's got colors and all that, but it's here. See? So if you cannot find a periodic table, you can always go looking for this one. And it's got color coordination of different things. So it's a really good periodic table. All right.
Now here,
Okay. Let me go
just
back.
a minute, you'll get the phone this point, okay?
So we are going to, like I said, start with this next one, which is, we're going to start with the basic chemistry because it's kind of like a review of what you should already know about atoms. And you may not remember. So. Okay, so here we go. So there is a very big difference between atoms and elements. If you're looking at anything in biological or any kind of compound. So an element basically is a form of matter that can be broken down into more unique parts by either chemical or physical means. In other words, it is as small as you can get. Just like if you asked what is the unit of, the basic unit of life is a cell, right? So if you broke that cell up, you could break it up into its parts, but it would no longer be a cell and it wouldn't function as a cell. Same thing with an atom. Atom is the basic unit of matter, right? And if you broke it up, it wouldn't be something else. It would be no longer an atom. You still would have the parts of it, but you wouldn't have the whole atom. So that's why it says it cannot be broken down more, okay, which is true. Right? An element is basically a collection or one. It just depends. Atom of the same thing. So if you have, let's say, let's look at this example right here. It says you have a brick of pure gold. That would be an element, right? So you have the element of gold. Because no matter how many times you broke it up, every atom would still be gold, right? So atoms are the basic unit of matter, but an element is one or more elements of the same kind of atom, okay? So that's what this is. Now, this is a good little chart to look at. You might want to write it down, what you have here. So these are the parts of the atom. Just like in the cell, you have all those parts. You have the nucleus, you have the mitochondria, you have the reticulum and all that stuff. So in this case, we're looking at proton, neutron, electron. And the charge for a proton is positive, for a neutron is neutral, and from an electron is negative. If you notice, the word P starts with positive, it starts with P, so there's protons. So if you remember that, a neutron, it starts with N, so it's neutral, right? And The electron, yeah, it's negative. You just got to remember it's a bit of a proton. Now, as far as mass goes, the mass of a proton is this amount. The mass of a neutron is that amount, and the mass of an electron is that amount. If you normalize it to an atom, then you can say it's about 1 atomic mass unit, and the neutron is an atomic mass unit. But the electron is 0 because the electron does not bring in enough mass to the total mass of an atom to count. Okay, so what we say is it's negligible, right? It does not count. You don't have to count it because there are just simply not enough atoms in the biggest element to make a difference. Enough electrons, sorry, in the biggest element to make a difference. So it doesn't add any mass. However, the nucleus, which is composed of the proton and the neutron, is where all the mass is in the atom. So you have the nucleus in the middle, and you have the electrons surrounding that nucleus in what is known as an electron cloud. And the electron cloud, like I say, it's basically mass.
This
has
drink,
no mass.
Bella?
Okay,
One
and
for Williams?
if you look at the symbols, you will have protons will be positive, neutrons will be. When I actually write my proton neutron, my symbols are a little bit different. So I'm just gonna write them here for you below. Instead of P or positive, I actually use a P with a plus, like that. For the neutrons, I will use this. And for the electrons, yes, I will use that. Okay, so if you see me write that, you will know that I'm saying protons, neutrons, electrons, okay? And that is horrible. Why did I have yellow? I don't know, but yellow is hard to see. All right, there we go. But now I've written it already, so. All right, so let's clear those drawings and keep going. All right, so for the rest of this, okay, so like I was telling you, a nucleus is a very small, dense area in the atom. It is located in the center, and it contains all of the atoms, protons and neutrons, which account for over 99.9% of the mass. So basically, like I said, the electrons are so light that they do not really bring in any mass. So the mass is all contained in the nucleus. So if you picture a football field and you put a marble right in the middle, that marble would be the nucleus, and the football field would be the electron cloud, which is funny because the electron cloud is much larger than the nucleus, yet it is more dense, right? As in it weighs more, and it does. All right, so remember that the electron cloud is where the electrons are, and they are free moving. In other words, they do not stay still. They're always running around in different directions. They're not all going one way. No, they just go all over the place around the nucleus. All right. So what makes an atom an element? This is the main thing that you're going to have to remember. Very important, right down here. You see how it says the atomic number is equal to the number of protons? So write that down. That is important. Very, very important. Because you recognize which atom it is, which element it is by the number of protons. So if I say this element has 4 protons, then you have to look for the element that has an atomic number of 4, which in this case would be, if I'm not mistaken, that is who has 4. Hold on. See, I told you we would be looking at that. at that periodic table. And I don't happen to have mine right up in my face, so hold on, let me go grab it. Because I do know these, but I don't want to be wrong, tell you the wrong thing. So I'm gonna say it is, but I'm not 100%, so I'm just gonna not say that. But if you look up in your periodic table that I gave you, and you look at yours, what does it say? Oh, here we go, there's mine. I found it, okay. I just was doing some stuff and had moved it over to the side. Okay, so 4, element 4. See, I was right. It is beryllium. But like I said, I didn't want to say anything because I'm not 100% certain. So the atomic number in the periodic table that I gave you is the number on top. Okay, in that little square that each element has is the number on top. So when you're looking at that number, you know the atomic number is equal to the number of protons. So if I asked you how many protons does aluminum have, then you would have to look at your periodic table, look for aluminum, which is Al, right? And once you find it, you look up at that number above, and that atomic number is the number of protons. And the answer would be 13, okay? So that would be element, when I will call an element by its number, I will say element 13. So element 13 is aluminum, okay? Or element 16 is sulfur, or whatever it might be. All right, so let's go to the next one. So this is the takeaway for this slide. Very important right here. Let me spotlight it because I'm just running around without. If I don't have a spotlight, you can't see what I'm doing. See right here, this one little sentence right here. Atomic number is equal to the number of protons. Make sure you write that down and remember it. This is very, very important. Okay, so let's keep going. All right, so then we have the atomic mass. That's the number below that periodic, on the periodic table, on the square below. Okay, the atomic mass of a proton is 1 AMU. The atomic mass of a neutron is 1 AMU. And the electron is 0. We looked at that. Then the mass of an atom is simply the mass of the protons plus the mass of the neutrons. Get that? So right here, atomic mass. Once again, I'm going to spotlight it so that you write this down. Atomic mass is equal to the number of protons plus the number of neutrons. You see that right here? Very important. All right. Now, another thing we need to know is that you can find the atomic mass of any element under the element's name, which is what I just told you. Now, if you look at that number is not a whole number. And the reason that is, and we will learn to calculate it too, because atoms can only have whole protons and whole neutrons, it makes sense that the atomic mass would be a whole number. But since the mass of the periodic table isn't a whole number because it's an average of all of the isotopes of that element, which, remember that. Okay, so when you are looking at giving the atomic mass of something, you are going to give a whole number. So let's look at lithium, for example. Lithium is element 3. And you should be looking at your periodic table as I tell you this. So lithium, element 3. You notice on the bottom it says 6.94. That 6.94 has to be rounded up to the nearest number in order for you to do the mass, okay? So it would be 7, right? So since you have 3 on the top, that means you had 3 protons. So how many neutrons would you have? Well, you have to subtract that 3 from the 7 that you just got. So 7 minus 3 is 4. So the answer is the atomic mass. And see, if we were to write it in, let me show you what I would do. Okay, so the atomic mass, which is 7, is equal to the number of protons, which is 3, plus the number of neutrons, which is 4. You see that? That is for beryllium. This is for this element called beryllium, okay? So you see, any element that you do that way is gonna have to be right, okay? So let's clear that. Let's do another one. We were talking about aluminum, okay? So aluminum, the atomic mass is 27, number of protons is 13. So that means the number of neutrons is 14, right? Because 27 minus 13 is equal to 14. So in order to figure out this, right, you have to subtract these two. So you could say, we could reverse this and say that in order to find the number of protons, the number of neutrons, you have to take the atomic mass minus the number of protons to get the number of neutrons. You see that? See how I just changed the signs, but it's exactly the same. All right, so that's how you need to do it. All right, so write that down. Make sure you know this. All right, let's clear that and let's keep going. And that was for aluminum, by the way, that I just did. All right, so there we go. So we talked about an isotope. An isotope is two atoms of the same element with different atomic mass. Since we know, right? Since we know that every atom has its number of protons, that means the only thing that can be different is the number of neutrons. So let's do carbon, for example. Okay, so carbon 12, that means that it weighs 12. So that means that your number of protons and neutrons is 12. So that's your atomic mass. Right here, this is the atomic mass. And we know, oops, sorry, I meant to put minus, not, there we go. Okay, so the atomic number of carbon is 6, right? So that means the number of protons is 6, which means the number of neutrons. And remember, I told you I would call it 6NO. Oh, let me make that a little prettier so you can see it better. Okay, there we go. All right, so this is the atomic number, right? The atomic mass right here, the atomic mass. This right here is the number of protons. And that is what gives you the number of neutrons. You see that? So if you take the atomic mass, subtract the number of protons, which is the atomic number, right? Or we can call it AN on the top. In your book, they call it atomic. So when you write an element, you give the symbol, you put the atomic mass on top and the atomic number on the bottom, okay? So that right there is telling me everything I need to know about carbon. All right, so in this case, we have 12, the mass, and we have 6, the number. So this one is known as A in your book, and this one is known as Z in your book. So just remember A to Z, right? So that you remember which order to put them. So A is the atomic mass. And so A equals the atomic mass, and I'm just gonna call it AM for short. And then Z is the atomic number. Right? So that's what we want to remember. All right, let's clear that. All right, so let's do this carbon 12. Okay, so carbon 14. 14, we still have the same atomic mass. So that means we have 8 neutrons. See how the neutron changed from 6 to now 8? That's because we have this element. So the one thing that can never change, will never change, this is always going to be the same, but this one can change. Okay, changes. That's supposed to say changes. There we go. All right, so the atomic number will never change, but the atomic mass will change because the number of neutrons can change. Got that? All right, so let's calculate oxygen. Okay, so oxygen is 16. We know that element 8, right? So that means we have 8 neutrons for oxygen 16 for this one. Now let's do oxygen 18. So oxygen 18, we have 8 always, which means we have 10 neutrons. You see that? See? So these two changed, but these two did not. You see? Okay. So when these two change, and by the way, this is supposed to be an arrow, not a 5. It looked like a 5 for a minute there. I meant to say these two changed like that. Changed arrows. There we go. And those two did not. Okay. So the next one is hydrogen. Just so that you know, hydrogen is the only element that has no neutrons as a normal element, because hydrogen is 1, right? The atomic mass is 1. The atomic number is 1. That means you have 0 neutrons. That's for hydrogen. For deuterium, which is this one, right? Deuterium is this one. So that means you have 2 minus 1, and you have 1 neutron on that one. And then you have 3. So 3 minus 1 equals 2. You have 2 neutrons on that one. So you can see these are what is known as the isotopes of hydrogen. You have 3 of them. And this one is known as protium, by the way, just so you know. That's a U. It's hard to write all the way down there, but that's known as protium. Oh, and I put E, I meant to put I. That's supposed to be an I, not an E. Protium, there we go. So you got protium, deuterium, and tritium. Those are the 3 isotopes of hydrogen. Protium has 0 neutrons, deuterium has 1 neutron, and tritium has 3 neutrons. I mean, 2 neutrons, excuse me. All right, and the atomic mass is 3. All right, so that's how you figure that out. Don't forget that, because that's very important. All of the stuff we'll be doing will be about this. All right, so the next thing, normally atoms don't have a charge, right? Normal atoms don't, neutral atoms don't. But there are, remember we learned that there's a possibility that they can lose electrons, and I showed you how they lose them. It's still written on the board. Element 1A, remember all the elements in column 1A will lose 1 electron, on 2A will lose 2, and 3A will lose 3, and 4A can lose or gain 4, in 5A they will gain 3, in 6A they will gain 2, and in 7A they will gain 1, and 8, well, they're already full, so they don't gain or lose. All right, so that's that. Remember that. So when you lose electrons, right, this is what you want to remember. If you lose electrons, your charge will be positive, right? If you gain electrons, your charge will be negative, because electrons are negative, right? And since electrons are negative, you will have more negative charges. If you lose electrons, since they're balanced, right? So you have the same amount of positives. Let's say this is beryllium, right? Okay, so you have 4 electrons and you have 4 protons. But if you lose 2 electrons, which is what elements in 2A do, see, you would end up with 2 extra positive charges. Therefore, the charge would be +2, you see? And that's exactly what you're doing. So if you lose electrons, you get a positive, and the number depends on how many. Okay, so let's clear it up. All right, so one thing we need to remember is when you form an ion, you can either lose or gain. And if you lose electrons, or gain electrons, you have a different type of ion. So if you gain electrons, which means you have a negative charge, you have an anion, okay? Anion. If you lose electrons, you have a positive one, and you have a cation, right? So when you write the ions, you write the ion of an atom. You always put the charge in the superscript. Superscript means above. So let's say we're writing beryllium like I was doing. So beryllium, which loses 2, would be up here, 2 plus. You see that? That's a superscript. It goes above. All right. And always put the charge to the right. So remember how we learned that the atomic mass goes on top? So in this case, beryllium would be 9 and 4. And if you had the ion, that would be how you would know every atom, every piece of information that you need. You know, you have 4 protons. If you subtract 2 from that, you have 2 electrons in this case, right? At this point, but and the last thing you know is that 9 minus 4 is 5, so you have 5 neutrons. You see, this atom right there, that is how you would describe it. You have 4 protons, 2 electrons, and 5 neutrons in the beryllium ion. Okay. Clear. All right. So in this case, sodium. Okay, you notice sodium is being written as sodium plus. So this is the sodium ion. Sodium is 11, the mass number, and oh, sorry, no, it's 23. I don't know what I'm thinking. Wrong way, wrong place. Okay, it's 23 on the mass and 11 on the sodium. So if somebody asked you, how many protons, neutrons, and electrons does this have? Well, you would say protons, we have 11, because this is the protons, remember? Neutrons, we would have 12, because you subtract these 2, right, to get that 12. And then electrons, you normally would have 11, but you lost 1, so you have 10. You see that? That's how you would know, okay? That's for that sodium. Let's do the next one, chlorine. Okay, chlorine has a negative charge. So the chlorine ion, oops, let me clear it. Looks terrible. Okay, let me try it again. Chlorine ion, there we go. The chlorine ion has atomic mass of 35. So 35 goes on top. And it has 17 on the bottom. So if we were to say, how many protons do we have? We have 17, right? How many neutrons do we have? We have 18, because we have 35 minus 17 is 18. And then how many electrons do we have? Well, we gain 1, and we would normally have 17, so we have 18. You see that? That's supposed to be an 8, and it doesn't want to come out. There you go, 18. So that's how we know. Okay, so let's do sulfur. Okay, sulfur -2. All right, so sulfur is going to be, all right, let's look for it. It's element 16, so we know that 16 goes down here. And the mass for sulfur is 32.07, so we round it to 32. All right, so we have protons, we have 16, right? We have 16 neutrons too, because 16 minus 32 or 32 minus 16 is 16. And how many electrons do we have? Well, we would normally have 16, right? But we gain 2, so we have 18. Okay, see that? So that's how we can tell how many electrons, neutrons, and protons there are in an element. So let's do a little exercise on that. All right, so right here. All right, so right here we have an exercise. Remember, number of protons is what identifies everybody. So this is what tells me which element this is. So if it's 8, all you have to do is look in your periodic table for element number 8. And you see that this is oxygen. Well, I'm not going to write the word oxygen on there. So I'm just going to write the symbol. All right. The atomic number in this case is 8. The atomic mass, if you look at oxygen, is 16. So there is no charge, right? Because you have the same number of protons as you have electrons. So the charge here is 0. And that's a 0. So just go like that. So you know that's 0. All right, potassium, right, is K, right? We know that. The atomic number for potassium is 19. We're looking for that. Remember, the number of protons is the same as the atomic number. So these two are exactly the same. They're equal, right? So when you are looking for the number of neutrons, we have to subtract this minus this. So that gives us 20, correct? And based on this charge, we know that we have lost an electron, and we normally would have had 19. So we have 18. See that? See how I did that? All right. Now this one's going to be a little more difficult because we don't have a whole lot to go on, but we do have a charge of -1, and we also have bromine. So since we know this is bromine, right? Bromine is element number 35. So we know the atomic number is 35, which means the number of protons is 35, which means when we add those two, this is 70, right? Oh, no, 80, sorry. I said 70, but it's 80. Bromine is 80. Yeah, right? Because 35 plus 45 is 80. So we're going backwards this time. And then we have a -1. That means we gain 1 from how many? From the 35 that we had. So we have 36. You see that? And the last one, the atomic number is 30. So we look for element number 30, and that is zinc. Zn. Okay. Okay. Remember, this and this are always the same. We need to put a 30 there. This minus this gives me this, right? So that is 35 right here. And then the last thing, if this is 30 and this is 30, then our numbers have not changed. So that means the charge is 0. You see that? All right, so you might want to copy this before I erase it, or take a quick picture of it or whatever, but I'm going to erase it here in a minute. It's coming. You ready? I'm clearing it. All right. All right, so that was an example of how you would do math with these. Okay, so remember, you gotta be able to do this. So the electrons are, now what we're gonna do is we're gonna look at the Bohr model. Bohr model, you notice the key here is that it can only be correctly drawn for elements 1 to 18, okay? Because the actual model was only made for hydrogen. But we're okay until element 18, which is argon. Okay, let's clear all of that. Now let's look at the rules for the Bohr model. Okay, so the Bohr model says, sorry. The Bohr model, thank you. The Bohr model says that each element, each level can hold 8 electrons, except for the lowest, which is the first energy level, which is the one in blue, that can only hold 2. The electrons in the highest energy level are called valence electrons. So this right here, this word right here. Valence electrons is a very important term. We will be definitely knowing how to do that here shortly, but valence electrons are important because they are the only ones that are lost or gained. So, and you have to know what your valence electrons are, and it's easy because each group number tells you that when there's 7As or 8As, or but not the B's. The B's do not tell you that much. Okay. So in order to do fluorine, remember the rule says that we have to put 2 electrons on the first level. So we're going to do that. There's the 2. But we have a total of 9, right? So that means we have 7 more. That goes to the next level. So we got 2, 4, 6, and 1 more 7. And that's a total of 9 electrons. And that's how you do the Bohr model. All right. So now we're going to remember 2 things. Notice that fluorine has 2 electrons in its lowest energy. Okay, so I'm going to highlight that. 2 electrons in its lowest energy. That means these are the 2 valence electrons. That means this. Sorry, not in its valence, sorry. And 7 electrons in its valence electron. Okay, so the ones that don't matter are those. Those are known, and I'm going to put them in a different color. That's why I erased it. Okay, so the, sorry, I said a different color. Come here, you. Okay, draw. Okay, there we go. This is known as your core electrons. And this is known as your valence electrons. So the amount of electrons that are on this level right here, that's your valence, because that's your outer electrons. And there were 7, right? So you have 7 valence electrons. Let me clear up this drawings. I don't need this stuff on here because you can't see. So you have 7 valence electrons. And if you look for fluorine on your periodic table, you will notice that fluorine is in 7A. 7A, 7 valence electrons. See that? The other thing that you will notice is that you have 1, 2 energy levels, right? And fluorine is in column 2. Sorry, fluorine is in column 2, which means that we're in period 2. See? So the energy levels are known by the period, and the the valence electrons are known by the group. So this is group 7A. See? Groups are columns, right? So these are groups, and these are periods. Okay? Let's clear all that. All right, let's keep going. All right, so let's do these. And I'm going to do one at a time because I can't do all of them right here because I have to do them with my fingers. So I'm going to do lithium. Lithium, the element itself is 3 and 7, if I'm not mistaken. Yeah. Okay. So we know that we have 3, we have a core, right? We have the nucleus with 3 protons. That's a 3. And 4 neutrons. So you write that down always in the nucleus. And then you put your elements, your number of electrons. So we really only have 2 electrons. So we're going to put 1 electron, 2 electrons on the middle. Remember, it's always 2. And only 1 on the outside, 1. So once again, this indicates that we're in group 1A. And we have 2 electron levels. So that means we're in period 2. And that is correct, isn't it? Look at where lithium is. Group 1A, that's column 1A. See that? And then we're in period 2. That means we're in the second row on the periodic table, which is correct. All right, let's clear that. And that's how the Bohr model would look. All right, now let's do nitrogen. Okay, so nitrogen is going to be 7 and 14. So 7 down here, right? And 14 here. So that means we have a nucleus with 7 protons and 7 neutrons, because 7 minus 14 is 7, right? I mean, 14 minus 7 is 7, right? Okay, and then we have 14. We have 7 electrons that we need to place. So we got the first 2, right? So we always do the first 2, 1, 2. And then we got the next. We got 5 of those, right? 2, 4, and then you got 5 total. All right, and there you go. And this is 2. It's kind of hard for me. You know what? I'm gonna stamp them instead. Let me clear these things. I'm gonna stamp them. That's what I'm gonna do. I'm gonna undo some stuff. Okay, then I'm gonna go ahead and do the next one. Okay, so I'm gonna go ahead and do that. And then I'm gonna stamp my electrons, because that'll make it much easier for me to do. All right, so I'm going to stamp them here. All right. There, these are my electrons. See there?
All right.
That way you can see them better. Then here and here, these go together, and then these go separate because they are not paired. And there you go. And that's how it looks. That's nitrogen. All right. And once again, we are 5 electrons on the outer shell, right? Which means we're in group 5A. And we're in period 2. That's what that tells me, because we have 2 levels, 1, 2. We're in period 2, and we got 5 electrons on the outer shell. So we're in group 5A. All right, and then we'll clear this one and we'll do chlorine. Now, chlorine itself, this is where it's going to get a little interesting. Chlorine itself, just the element chlorine, is 35 on the top and 17 on the bottom, right? And we have a charge. So in this case, we're going to have 17 protons, 18 neutrons, and 18 electrons, because the charge is telling me we gain 1, and we gained it from the protons. So we need to now make this 17 here. This is our nucleus. This is 17 protons and 18 neutrons. Okay, and then from there, we got to do our first level, our second level, and we're going to place these electrons in there. So we got our first level, got 2. Our second level, we got 8, 2, 4, 6, 8. So we still have 8 left, right? 8 actual electrons left. So we need more. We need 1 level more. And then we need to place 8 electrons in here. So we got, and I'm going to place them in a different place so you can see them better. And then we have 1 that I'm going to put in a different color. Why am I going to do that? Because this electron, oops, sorry, undo that. This electron actually came from another element because it is an ion. So that electron didn't just grow from it, right? It came from somewhere else. Okay, but I want you to pay attention to something else. All right, so we had normally 7, right? Because that would be 7 of them. You notice that red one is not part of chlorine. So normal chlorine, if this hadn't had this negative, we would have had 7 electrons on the outer shell. So that means we are in group 7A, which is correct, right? And we are in period 3 because we have 3 electron levels. And look, if you look at your periodic table, you will see that chlorine is on the third row of your periodic table. And that's where it is. So that's what you want to know. You want to know that rows and periods are related to the number of things that you see. Okay, so let's keep going. Go to the next one. All right, so valence electrons. This is what we were talking about. Remember, oxygen has 6 valence electrons. Oops, sorry. I meant, which means it's in group 6A. Hydrogen has 1 valence electron, group 1A. Hydrogen, oh, what we have. Okay, one group 1A. So a total of, and this is water. So if we were to draw water, let me clear all that. Okay, clear all of this. Okay, so if we were to draw water, we would have oxygen. Let's make oxygen red. Okay, so we would have, and I'm just not gonna bother with the nucleus too much. So we're just gonna say 1 and 2, and then you're gonna have, oxygen has 8 total electrons, right? So we're gonna have the 2 there, which don't matter, but then you have these two, and these 2. All right, and then along comes hydrogen, and hydrogen we're gonna make blue, and hydrogen has a blue core, right? So we got 1, oops, let me undo that. I wanna make it thinner. Okay, so that's your middle. And then you've got your electron. You have 1 electron. And that 1 electron, and then here, we're gonna have another hydrogen. Okay, right here in this area. And we're gonna have a nucleus. And each one of those has an electron. So the electrons right there and the electrons right there. If you notice that these 2 are gonna form a bond, but this is what it's known as a bond. So if I redraw it, let me redraw it. Undo that. No, undo. I'm gonna undo all of these so that you can see where I would put it. Okay, so I would put my electrons right on this. Why are you being mean to me? Okay, right on there and right on there. And we would draw the hydrogen a lot closer because now hydrogen has bonded to this. You see? So this is water right here. See? H2O. See? 2 H's, 1 O. See? So that is water, and that's how it bonds. It all matters on the valence electron. So you've got to make sure, right, that you know what you're doing with the valence electrons very quickly. All right, so let's go. All right, next one. All right, so this is what we learned. The columns of the periodic table are called groups, right? Oops, sorry. I need my, okay, they're called groups. And groups, you have 1A, 2A, 3A, you know, like that. And that tells you how many valence electrons are in that group. So if you have group 1A, you have 1 valence electron. If you have group 8A, you have 8 valence electrons, except for helium, which only has 2 because he only has 1 layer. Okay. So you are always looking for 8 electrons on your outer shell. When you have metals, remember metals will lose electrons and they become positive. Non-metals gain electrons and they become negative. And you have to remember that. All right, so that is your groups. Now you have the other information in the periodic table, which is your columns. I mean, your rows, excuse me, your rows, which are called periods. What do periods tell you? The period tell you how many levels, total levels there are in that period, in that atom. So if you have an element like magnesium, okay, magnesium is on the third row. So he is in period 3. That means we have 3 electron levels in magnesium, whereas we only have 2 electron levels in beryllium because beryllium's in column 2. Okay, so that's basically all we know about what there is to do here. Now, what we're gonna do is we're gonna do some practice again. Right, so I'm gonna close this and we're gonna go to where it says atomic structure practice sheet. You see here? All right, we're gonna grab that and we're gonna complete it. And we're gonna enable editing so I can actually type. Come on. It's not letting me enable editing. There we go. All right, so we're gonna type directly on it. Ooh, that's too much. I wanted to make it bigger so you could see it, but not that big. So we can all see it. Okay, so we're gonna complete it. And you're gonna help me complete some of these. All right, so I'm gonna put text. I'm gonna actually complete it with my computer. No, I don't want text, I want my mouse. Okay. So we're gonna actually put numbers in here. So magnesium, the atomic number for magnesium is 12. And I'm gonna make these red. Okay. How do I know that? Because I'm looking at the periodic table and magnesium is element number 12. The mass number is given to us, as you can see right here, right? That's the mass number. So it's given to us, and that is 24. Notice I am just writing down. Okay, nobody told us anything about that there's a difference, so we're going to assume, and plus there's no charge here, that there is no charge. So that means our protons are also 12. Remember, protons and atomic number are the same. The neutrons you get by subtracting the mass number minus the atomic number, which is also the same as protons. So you can say mass number minus protons equals neutrons. So we got 12 again, right? And then the electrons, they're normally, if you have no charge, they're the same as the protons. So we have 12 also. Now the next thing is to figure out if this element that we're writing in here is a neutral atom, an ion, or an isotope. How do we know that? Well, if we have no charge, it's not an ion, right? So if the electrons are the same as the protons, then no charge. So no charge, so it's not an ion. And if the number, the mass number is different from the one on the periodic table, so if we look, it says 24.31, which remember, we got to round it. So that makes 24. So no, so this is a neutral atom. And I'm just gonna call it Na because neutral atom doesn't fit, okay? So that's what we know. Okay, now, this one is not given to us who it is, but we're given the atomic number. The atomic number tells us who it is, right? The atomic number 19 is potassium. So we know this guy is K. So this is a new find, right? And we know that the protons are 19 because the number of atomic number is the same as the proton. So we know that. Now we've been given the neutrons, but we haven't been given the mass number. So if we add these two, right, that gives us 39. And remember, the mass number is the number of protons per neutron. So we just did that. Now, we have a charge? No, we don't have a charge. So that means our number of electrons is also 19. All right, so what can we say? This is another neutral atom, right? Because this periodic table is the same. I just looked at it and it says it is 39. So, yep, 39.1, so it's 39. So we are not changing anything. Notice this one's giving us a plus already, but we don't know who it is. All right, so we got a mass number of 23. We have a charge of 1. We have how many electrons we have. So normally, when we are plus 1ing, right, that means that we lost an electron. So originally, we had 11 electrons, which means we had 11 protons. See how I figured that out? If we had 11 protons, that means our atomic number was 11. And 11 is sodium, isn't it? Okay, so we know that. How many neutrons do we have? Well, 23 minus 11 is 12. And now we can answer. Let's look and see. Sodium is 22.99, so 23 is the normal number. So, but we have a difference between here and here. And we also have a charge. It's indicated. So this is an ion, okay? Ion is different number of electrons, remember that, as protons. So if we have a different number of protons and electrons, we have an ion, okay? All right, this one is giving us the mass number of 19. It's telling us it's fluorine, right? Fluorine is number 9. All of that is known. We also know the protons because of number 9. So all of this I'm going to put in red because we just figured all of this out. So all our new information we're putting in red. The other thing we know is that we have a charge of -1. How do we know that? Well, it's given to us. See it right there? Okay, so we got a -1 charge. Which means, okay, so now the next thing to do is to figure out how many neutrons we have. Remember, we have to take the mass subtracted from the protons, that gives us 10, right? We have 10 neutrons. How many electrons we have? Well, we have an extra electron from the 9 that we used to have, right? So we have 10. So this is our number of electrons that we have now. So this, if our 19 is the normal number for fluorine, which it is, then this is just an ion. All right, we know it's an ion because we have a charge. That means our number of electrons and protons are different. See how they are? Protons 1, electrons 10. They're different from each other. So that means we have an ion. All right, next one, we have the atomic number of 13. That means that protons are 13. That means this is aluminum. How do we know it's aluminum? Because atomic number 13 tells us this is aluminum. So we know that. We know this. And that's all they gave us, right? They gave us everything else. All right, so the mass number minus the number of protons gives us the atomic number.
How are you this morning?
I'm pretty good.
I'm good.
Okay.
Any eye pain today?
A little bit.
What's going on?
Hmm,
I'm sorry.
true.
Okay.
Okay, so over here, we have a charge of +3. +3 indicates we lost from 13. We lost 3. So the number of electrons is going to be 10 again. You notice there's a pattern emerging. They're all 10s. Why are they 10s? Because everybody wants to look like their noble gas. That is either before if it's a metal or after if it's a non-metal. Okay, so in this case it's neon. So they're all looking like neons. All right, next one. Okay, notice we have 1 proton, which means our atomic number is 1, which means this is hydrogen. The mass number, well, we know the atomic number per neutrons is 1, right? Because 1 plus 0 is 1. So this is, it's also charge of 0, so that's a 1. Oh, you know what? Let me undo stuff because I need to. No, I gotta go back. Okay, never mind. Okay, so we knew, what did we know? I'm sorry, I blanked out here. I think we knew the number of protons. We did not know this. I forgot to change it. Yeah, we did. No, we knew that. We didn't know that. There we go. I think that's how it went. Okay. So this is a neutral atom also. I think that's how it went. I want to say that's right. I think one of these. Yeah, this one. We have to figure that one out too. Okay, there we go. That's all we have. All we have information, and we're figuring it out. How do we figure it out? By looking at our periodic table. Periodic table tells us all these things. All right. The next thing we have here is, do we have how many electrons, right? We have the number of neutrons. We have the mass number. Okay. So we know that the mass number minus the number of neutrons gives us the atomic number, or the number of protons. So this element 12, right, is magnesium. So we know this guy is magnesium. And we just figured out this. And we figure out that. That's all so far. Right, we have 10 electrons, and that is not the same number. So that means we have lost 2. So we have a charge of +2. So this right here is an ion. Okay. Right. So that's how we are going to keep going. I want you guys to work the next, let's see. I'm going to put numbers on these just because I can. All right, so we're going to put 1 here, 2, 3, 4, 5, and 6. So since there's only 2 of you, Henrietta, I want you to do the odd numbers, and Jacqueline, you need to do the even numbers. And I'm going to give you 10 minutes. I think 10 minutes probably good enough to do 3. And you come and tell me the answers here in a minute, okay? So you're doing the odd numbers. You know, so I got 1, 2, 3, 4, 5, 6. So the odd numbers for Henrietta, so 1, 3, and 5 for Henrietta. And Jacqueline, you're doing 2, 4, and 6. And I will be waiting for answers in 10 minutes. At 11, exactly 11, I will come back and ask. I want you to work on it, though. Don't just sit there and wait for me to give you the answers. All right, ladies, it's almost time to get those answers. Got 2 more minutes. You're supposed to be doing, Henrietta, you had the odd one, so you had 1, 3, and 5, and Jacqueline, you had the evens 2, 4, and 6. So I just put numbers on there, but I'm going to erase them so that we can actually get the right answers in there. So I just wanted you to have those. Okay, ladies, we are ready to get those answers. All right. So Henrietta, you were supposed to do 1, 3, and 5. What did you find? Okay. All right. All right, Henrietta, I don't think she's on there. How about you, Jacqueline?
For 2, I want to say it's 16.
Okay, so yeah, so this one is 16 is what you're saying?
Mm-hmm.
Okay. That is correct, but you gotta fill everything else. So let me make it a little bit smaller so we can see it all. There we go. All right. So 16, yeah, that is correct. That is the atomic number because the protons are 16. So that's correct. What about the mass number? Did you come up with one?
No.
Well, remember the mass number is the number of protons plus neutrons. So if you add 16 plus 16, you get 32, right?
Yes, ma'am.
Okay. All right. So what element is this? It's element 16. So what is in the periodic table for element 16?
Element 16. Let me go see. Where is my periodic table?
I don't know. I did show you there's one on,
On Moodle.
yeah, one on Moodle. Hold on.
Let me see.
I put it up. Put it out. That it? Nope, nope, nope. That one? Nope. No, nope. I don't know where it went. Nope.
I have.
Not it either. I had it. I thought I had it pulled up, but I guess I don't anymore. Yeah, no, I don't. Okay, I must have
I
pulled
have one.
it up and I didn't mean to.
For 16 is, you said the element?
Yeah. Remember, you have to look at the top number.
Is oxygen?
No, sulfur. have to look at the top number.
Oh, you shall do it. Sulfur. Right down below oxygen.
Mhm. The top number. So the top number is 16, right? That's the atomic number. And the mass number is 32. All right, so how many electrons do we have since we have a -2? Remember, normally electrons are the same as the protons, but if we have a -2, that means we have gained 2. So if normally we would have had 16 and we gained 2, the answer would be 18, right?
Mm.
All right, so since we have 18, that means we have an ion. All right, so that is the answer to that one. All right, so let's do number 4. What did you get for that one? Could you do that one?
Let me see. I need help with this one.
Okay, so remember we said that +3 means that you have lost, right? And
Mhm.
since you've lost and you got 20, that means you started with 23, right? So that means your atomic number was also 23. So let me go ahead and put that in red. Otherwise I forget which one was the one that I'm filling in. All right, so which element is atomic number 23?
Number 23. Where is my thing? Let me find it. Is then the
Vanadium, right? So
yeah,
just
but
V. All right, so we know that. So the other thing we don't know is the mass number. So since they didn't give us anything, we can use the one on the periodic table. And vanadium's mass number is 50.94, right?
Mhm.
Which is 51. Remember, we have to round it. All right. So 51 minus 23 will give us the number of neutrons. And that would be 38. No, 28. Sorry, 28. Right? Because we got to add this too. Yeah, so it's 28. So we know that this is another ion. How do we know that? Because we have a charge, right? And that's what makes it. Or if you're looking at a different way of looking at it, the number of protons and electrons are different. And that tells us that's an ion. Okay. And the last one that you had was 6. Okay.
It's 106.
Okay, so atomic number is 106. That is correct. Which element is this?
106 is SG.
106 is Sg. That is correct. So seaborgium. All right. So we got Sg. We know the element because we know the protons and we know the atomic number, which is one and the same. Now, they gave us the number of electrons. That means we have 108. That means we had to have gained 2, right?
Mm-hmm.
So this is a charge of -2. We know that much. Now, as far as the neutrons and mass number, they didn't give it to us. So we are going to use the one on the periodic table, which is 266. No, not there. Sorry, that was -2. I meant here, 266. All right, so that's our mass number. So if we subtract 106 minus 266, we get 160, right?
100. Yes.
Okay, so that is our number of neutrons. So based on what we know, this is another ion. See, a lot of ions in here, hardly any isotopes as of yet. So Henrietta, you were supposed to do 1, 3, and 5. What you get for 1? You can unmute yourself so I can hear you. Unmute yourself so I can hear you. There you go. Thank you. All right.
I'm sorry, I'm at the eye doctor. I'm sorry.
That's fine. That's fine. I understand. So we have silver, right? Silver, what is the atomic number for silver? Look in your periodic table. Atomic number is the number on top, remember? So that would have been 47, right? If you look at the periodic table, I don't know if you have your periodic table with you since you are at the doctor's office. I didn't realize that. Oops, that's not the charge. I'm sorry. That's the number of protons, right? We know that the atomic number and the number of protons are the same. So we immediately write that down. You notice they gave us a mass number. That means we can get the number of neutrons directly. So 108 minus 47 is going to give us 61. Am I right? Yeah, I think that's right. 61. I think I'm doing this with my head. So, all right. Now, electrons. Well, we were not given anything that indicates that we would have any change. So there is no change in electrons. Therefore, the number is still 47. And this is just a plain old, well, let's see. What is silver? Normally, the mass number of silver is normally 108. So no, this is another neutral atom. So Na, because that neutral atom doesn't fit in here. Okay, so that's a neutral atom. All right, so number 3. All right, this one's a little different. Okay, so you notice that we have protons, which means we do have the atomic number, which is 1. Anything with atomic number 1 is going to be hydrogen, right? Because hydrogen's always 1. Okay. But the one thing we don't have the same is the number of neutrons, because 2 minus 1 is 1. And 1. And then there's 0 charge, so that means we have 1 electron. All right, so this is what we have. Now, let's analyze it. We know that it's not an ion, right? But we know that the mass number of hydrogen, if you look over here, it's normally 1, but here is 2. So that means we have 1 neutron that we didn't have before. Therefore, this is an isotope. This is our first isotope. Okay, let's do number 5. Let's look at it. Okay, so we have the mass number, we have a charge, and we have the electrons. So if we added 1 to 18, originally it would have been 17, right? So 17 is the number of protons, because since we added 1, we have to subtract it to get back the number, which means our atomic number is 17. And that makes this element chlorine. Oops, nope, lower L, there we go. All right, so that makes this element chlorine, which if we subtract 37 minus 27, we get 20 neutrons. And we have a negative, which means we have an ion. And if the periodic table mass number is also 37, which is not, then we also have an isotope. So we have both an ion and an isotope. And yes, you can have an ion in an isotope. It's the same as an element, you know, it's the same as an atom. So you can always change the number of protons, neutrons, and electrons. The only thing you cannot change, sorry, not protons, neutrons and electrons, but not protons. Protons you never change, because if you change the number of protons, you no longer have that element, because that's what identifies the element is what it is. So based on what I just said, Madalisha, since you're here, unmute yourself and tell me what you would do for the next one. Madalisha? Okay, she's not available, I guess. So 61 is a number of protons, right? So that means our atomic number is also 61, which gives us who this is. Who is this? Let's see, 61, element 61 is promethium, so PM. Oops, not there, here. Sorry, PM. Where did my, okay, I think I erased it accidentally. That was supposed to be 61 there. Yeah, there you go. All right, now we have 67 electrons. That means we have gained 6, right? So minus 6 here. Which means our number of neutrons, okay, so we have to subtract 148 minus 61. 148 minus 61 is going to give us 87, I think. Yeah, 87. Okay, so 87 is our number of neutrons. Now, looking at promethium, we see that the amount of the atomic number, the atomic mass is 148 here, but in the periodic table is 145. So this is an isotope. We also have a charge. So this is an ion also. So we got both. In this case, we have both. All right. Let's do the next one down. I guess she disappeared on me.
In the Broadway?
Okay. So this is tungsten, and W has an atomic number of, where are you, tungsten? There you are. Okay, 74, right? So we know that this atomic number never changes, right? So we know that 74 is also the number of protons. So we put that there. We also know that the neutrons is subtraction of 187 minus 74, which looks like 113 to me. I mean, you do the math, but I think that's right. Yeah, 113. All right, so 113 right there. And how many electrons? Well, normally we would have 74, but we've lost 6, right? Since we lost 6, we are not going to have 74, we're going to have 68, correct? And that makes this an ion for sure, but let's look and see if our mass number for tungsten is 187. No, it's not. So it's also an isotope. All right, so that's both. Okay, let's do this last one that is looking. We have 2 more. Okay, let's just last 2. All right, so once again, let's look at what we know. We know that our atomic number, or our atomic number, is the same as your number of protons. So this is 101, right? And who is element 101? Well, let's go look. Element 101 is mendelevium, MD. Oops, keep doing that. MD, no capital MD. There we go. So this is mendelevium, which we said was 101, which I already did that. Okay. And that means the atomic number, we are not given anything. So we're going to use the one in the periodic table. And that one happens to be 258. Right? We get that from the periodic table directly. But when they give us neutrons and protons, we can figure that one out ourselves. So how many neutrons? So 258 minus 101 is going to be 157, if I'm not mistaken. Yeah, it looks right. And that means we have 157 neutrons. How many electrons do we have? Well, normally we would have 101, but we've lost 4. So that's going to be 90, what? 7, right? but we lost 4, right? So this is an ion only ion, not an isotope, because we had to get the periodic table amount from there. Okay. I'll put this one in the center because that bugs me. All right, so the last one, we have the number of neutrons, we have the charge, and we have the electrons. So we've gained 4 out of 47. So originally this had to be 43. 3. Okay, so 43 protons tells me that I have an element, no, red, there we go, whose atomic number is also 43. And who is element 43? Well, let's go look. 43 is technetium. So we have TC. All right, we know that. Now, we already been given the atomic mass because we got both protons and neutrons. So this is 96, right? Because when we add protons and neutrons, it gives us the mass. The mass of technetium is 96. Now, officially, the mass of technetium is 98. So that means this is an isotope. And it's also an ion. All right, and there you go. That's how you do this whole table. It is, there's more to it because you were, just in case we had more. But I think we have good enough amount that we've done. And I'm going to take these numbers off now because this is not part of my thing that I do. But I had put them on there so that you would know which ones you were supposed to be doing yourselves, right? So ladies, you need to practice this stuff. All right. So what you need to do is you need to go to your Moodle, download this same thing, make a copy. Take a picture of this as your last resort, because all of these are correct, and compare them to what you get. So that way, whenever you are doing this, you can actually have an answer, that is correct. Now, when you do that, it's like you're checking your own knowledge, okay? So let's do one more thing. All right, let me go ahead and don't save it because I don't need it, but okay. So the next thing we're gonna do is we're gonna do a nuclear symbol practice. And this one you're gonna see, the table, a lot of people say the table is more confusing to them than this one, but you are going to encounter them either way. So if you're encountering them as a table, you have it. If you're encountering them as a nuclear symbol notation, then you have it too. All right, so for this one, what we're going to try to do is we're going to try to do how many number of protons, neutrons, electrons we have in each one. Come on. And we're going to be able to type directly. Okay, so for nickel, okay, so we're going to do protons. And we're going to put an equal, right? Oops, an equal. Okay, so protons. This one's going to be protons too. That's the easiest one. Okay. Then we're going to do the next thing, which we're going to do. Oops. For this one, we're going to do, we can do the neutrons, or we can do the electrons, but let's do the neutrons first. Neutrons, okay. Okay, and then we're gonna do the electrons.
They gave me the numbers.
We haven't figured them out yet. I'm just getting ready. Okay, now we need to answer. Okay, so how many protons does nickel have? Well, since it's nickel, all we have to do is go look at nickel, and it says 28, right? So we know that the protons are calculated by subtracting the mass number, which is that 59 that's up there, minus the 28. So this is going to be 31, right? And then we know that the electrons you calculate by taking the charge. If it's positive, remember you've lost. So if you take 31 minus 2, it gives you 29.
Right there.
There you go. That is correct. Now let's do the next one. Arsenic. Okay, arsenic. And 33. Okay, so we know element 33. Now how many neutrons? Well, you take 75, subtract 33 from it, and you get 42. No, not 42, 52. I don't know how to add. 52, right?
You've been teaching here
And then
before.
the electrons, this one's telling you gain 3 from 36. So it's 30, I mean, from 33, so it's 36. All right, the next one is cesium. Cesium, you're looking for it. It is 55. Element 55. So that means you have 55 protons. How many neutrons? So 133 minus 55 is equal to, that's an 8. That's a 7. So 78, I believe.
I'd like to, is that in both sides or just one?
And then you have a plus charge, which means you have one less than 55. So this is 54. All right. The tin, the protons for tin is 50. So that means the neutrons here is 69, right? And the electrons, well, we don't have a charge. So it's going to be 50 also. You see that? That one was easy because it doesn't have any changes. Now the last one, we have bromine. And for bromine, protons are 35.
All right.
Because that's our atomic mass.
So for the last
Atomic number, sorry. So the number of neutrons is 45, right? And notice there is no charge. So once again, this is 30. See how we were able to figure out which one's which based on what the information that's given to us. Now, we're going to do the exact opposite. We're going to take the numbers that they're giving us, and we're going to build this thing right here, right? Something like it. All right, so let's do that. All right, so we have, I'm just gonna put it way up here, and I'm gonna actually draw it myself. So I'm gonna draw it.
Right, talking about, yeah, right, was good.
All right, so
before.
34 protons. That's telling
Yeah,
me this
yes, we don't want that.
element is.
Yeah, you're right. I was with your
selenium.
shit. You know,
Okay,
we're having some
so we
learning
know this
there.
is selenium.
Yeah, all right.
Okay. We know that with 34 plus 45 gives us the atomic mass. So 34 goes down here. And then 34 plus 45 is 79, right? So 79 goes up here. And then we have 36 electrons, which means we gain 2. So we have a charge of positive and negative 2. You see that? That's how we built that one. Next one that we're going to build is this one. So this is this one. This one's going to be here. I'm not going to have enough room for all of these. So I'm just going to, I'm actually going to put this one right next to it. Okay, so this one, 80.
Do anything, is anything happen in conjunction with it, or you just start just get really blurry?
Okay, so this is lead. We know lead is 82 down here. And it's
Would you
giving
say
us
that
that we have
careful with left side, or is it
126
about
neutrons.
first
So
or
20,
first or the-
that is 20
208,
208, right? 208, yeah, 108 on top.
Let's see.
Oh, you moved to, that's good enough.
Oh, no, I just think we're just taking part. Are you in a lecture or?
Yes, I'm in lecture class.
And now we have 79 protons and 77 electrons. So that means we've lost 2, which gives us a charge of +2. You see that? So there's your nuclear symbol notation for that element. Now we're going to do this one, and I'm going to put that one over here. Sorry, but that's just the way it's going to have to go. All right. So we have 79 protons. (79 protons, 118 neutrons, and 77 electrons. So 79 protons is element gold. So this is gold. Okay. 79 goes down here. And we're adding 79 plus 118. That's going to give us 7. And then 197, right? 197. And then we have a difference here, which means that we have lost 2. And there's your nuclear symbol notation for the gold atom. This one's going to be for 10 right here. So 10, I recognize 10 because it's 50. Okay, so this is 50 right here. And this is 119, I think, right there, right? 119. Yeah, 119. And then you have 46 electrons, which means you have lost 4. All right, and then this last one, I'm gonna put here, sorry, but that's just the only way I can do it. All right, so this one is 18 protons. 18 is argon. So this is argon, AR. So 18 goes down here. And then we have 22 plus 18 is 40, right? And then we have no charge. So there's the answer, 40, 18. Okay, so that's how you do all of these. You have to figure out the numbers by looking at your number of electrons, protons, and neutrons for the ones. All right, and that concludes this part. Now, I had sent you a little message and nobody told me if they received it or not. Hope you did. Did you? Okay.
Did you send it on Moodle or email?
I sent it on Moodle. It's called an announcement, but it also supposed to go to your email.
Okay, so I'm gonna check my email.
Yeah, that's what I'm saying. So you should have gotten it. Hopefully, I just want to, I'm kind of testing it too, but I sent, see, the announcements are up here. Okay, right here. Announcements right there. So if you click on that, you would see the announcements that I put out. And those are supposed to go directly to your email. So it says we have completed the entire chapter 1. So as you finish both assignments, as soon as you finish both assignments, you can take assessment, which is test 1 also. Today we will start covering chapter 2. See you in class. And there it is. That's all.
So what is test 1?
Test 1, that is assessment 1. It's right here.
That's
Yeah.
Oh, okay. So I was getting started on a reading assignment. That's what I was over here doing.
Okay, reading.
Yeah, the matter.
The reading assignment, and then you do the chapter 1 and chapter 1, you know, both of these assignments. That's what I'm talking about. The reading assignment is mainly for you to read, you know, before you get to this part. And then the chapter 1 and application and chapter 1 assignment, both of these, after you do those two, then you do the test. And then we're starting on this one now, right?
Mm-hmm.
So then that's your reading assignment right now. And then after that, you can start doing these. Like, for example, we learned how to do protons, neutrons, electrons, and charges. Okay, since it's been too long, I guess it signed me out. All right, I'm gonna have to redo this whole thing. Okay, it signed me out because it took too long for me to get on there. All right, so let's say we're doing chapter 2 assignment and we're looking at it. All right, so you know what? I'm going to go home because I don't want to preview it. I want to look at it as you do. All right, so student view. I know some actions are not available in this mode. That's why I usually don't use it. But since what I'm trying to do is show you what you're going to do, then it makes sense to use that one. Okay, so this is your chapter 2 assignment, right? So you're going to go to your thing and you can begin it. Now, if you begin it, you can always save it. Remember that. Okay, there are 16 questions. Okay, so the first thing, okay, so this is about atomic theory, and that's part of your reading, so I'm not going to go there. That's just reading. This one, though, this is what I was telling you. See? Okay, so all of these, I gave them to you. But basically, you can say the electron is outside the nucleus. Okay, so where in the location outside? See? In the nucleus, that's these two. They're both in the nucleus. See how you just dragging in there? And I gave you this table just recently in that PowerPoint that we were looking at. Okay, proton, the symbol. Okay, let's see if I see it. Yeah, see, that's how I use it. I use the proton. That's my proton symbol. And neutron, the symbol is usually N0. That's how I do mine, but it's not N plus. So they're probably gonna say it's this one. Okay, because I don't see anything that belongs to it. Oh, there it is. No. I see it, never mind. I see it, there it is, N0, see? That's what I use. And then the electron is this one. These are your symbols that are up. Now, the charge, the relative charge. So they're saying, what is a relative charge? So +1 and -1, right? Because it's a negative charge. And this is a 0. Now, absolute C, I don't know what they're talking about there. So I'm just going to leave it alone and figure it out later. I really don't know what they're talking about. So the relative atomic mass unit, this is 1. Okay, that's weird. Okay, yeah, all right. So the relative atomic mass unit, this one's a little heavier than this one, right? This is weird. All right. And the other one would be 0 relative, because there is no, this one, I guess is this one. Now, this one is, I might be backwards, but we're gonna check. It's just that I've never heard these two things. Okay. I don't know what this absolute C is. I don't understand what they're asking me. What are they asking me? Absolute charge? It doesn't make sense to me. So I'm just going to check my work as I'm going. Obviously, those are going to be wrong. Okay, see, these are wrong. Why are these wrong? Oh, because I have them backwards. Ah, duh. None of these are negative. Duh. Sorry, that's a positive. So return to question. All right, so this, I don't know what it is. So that's what it is. I put the wrong. I didn't even notice I was putting the negative on there. I really did not. They're all positive, obviously. Okay. I don't know what the absolute is. I don't know what they're talking about. So I'm going to check my work now. And of course, it's going to give me those wrong. No, these are still wrong. The heck? But that's correct. It's to the negative 19. Oh, maybe it's to negative 18. No, because that's the atom. That's the electron. This is the proton. I'm trying to think which one this is. Because according to my PowerPoint, which I can go get again, we did that. Let's see. Let me go back to it. Just because I'm not sure what I'm looking at. I'm not sure what they're asking for. It's relative C. I guess it's because I didn't read the book and it probably tells you on there. But I don't get what they're asking me. That's why I cannot answer, is because I don't know what they're asking me. All right. See right here, when we did this one, that we looked at this PowerPoint right here, that's what I was going by. Is this one chart that we have in this PowerPoint. Hold on. Come on, open up. It's taking forever. There it goes. It's opening, but it's so slow. There it goes. All right, so this is the chart. See, 1.67, 1.6. It's 1.7 times 10 to the negative 27 and 9.1, but that's kilograms. So if you take it in grams, that's going to be to the 24, negative 24 grams and negative 29 kilograms. So that was right. I mean, 28 kilograms. So that was right. See, 1 AMU. That's what I'm saying. I don't understand what they're asking me. That makes no sense. See? They have 1.6, I have 1.7, but I don't know what they're asking me. Oh, that's why, because it is 1.7. Okay. All right, I got it now. All right, so I'm returning to the question. And these are wrong because they are, I don't know what I was thinking. It's this one. There we go. All right, now this, I don't know what they're asking me. Absolute C. Everything else seems to be okay. Charge, absolute C. Let me just look and see what that is. Okay. Okay, so it was times 10 to the 19th. Gotcha. All right, neutron has 0. We know that, but the electron is going to be negative, I think. Yeah, okay, I got it now. I know what they're asking me now. C, okay, C for Coulomb. Okay. Gotcha now. I understand it now. I wasn't sure what they were asking me at first because that C didn't make sense to me. And then the other one's a 0. It's always 0 because neutron doesn't have a charge. All right, now check my work. That should all be correct now. Yeah, there we go. See? So there's other ways of finding it out. Okay, so what they call it absolute charge, that confused me. All right, so there you go. There's your answers. See, since they didn't put any units, they screwed me up with that one because I don't know these by heart either. All right, so next, we're going to the next question. Okay, see, identify the isotope that fits the description. Okay, so you've got 47 electrons. All you gotta do is go look at your periodic table and see which element is 47. That is silver. So you grab silver over here, see, and put it here, like we just did. Now, 47 goes on the bottom. There it goes. And 68 plus 47 is 15 here. So it's 115. That's this one. See? Okay. The next one is 79 electrons, it says. So since the 79 electrons, it's not charged. So we are looking for an element that is 79. So it's gold. So this one's gold. 79 goes on the bottom. Stop it. And we have 197 mass numbers. So that's what goes on top. See, when it mass number is what goes right here. Stop it. I hate when that happens. That's because I have it so big that it's making it hard for me to. There we go. Now I can look at the whole thing. All right, so 86, the atomic number is 86. 86 would be radon. So we need Rn. And we need the 86 on the bottom. And you notice it says 136 neutrons. So we need to add these two. That is 2 and 8 plus 3 is 11, goes 1. So it's 222. All right, I think so. Let me see. 6 and 6 is 12, goes 1. 8 and 3 is 11, plus 1 is 2. Yep, that's correct. Okay. And then the next one is 76. So who is element 76? It's osmium. So we're looking at osmium, OS, there we go. 76 goes on the bottom. Remember we said that. And then what goes on top? Well, it's giving us the mass number. So 192 goes on top. Check the work and it should be correct. See? That's what we just did. We just did this. So I know you know how to do that part. All right. So as you can see, you can already do parts of your